Oh, hold on. Regular security audits, which is to conduct regular security audits and code reviews to identify and fix vulnerabilities. So one real life example of cross-site scripting is back in the mid 2000s. There was a very popular social network site. So similarly, around the time when Facebook blew up, there was a place called MySpace. So infamously, there's a Sammy Worm incident in which in a user named Sammy Kamkar discovered a XSS vulnerability on MySpace. He exploited this vulnerability to create a self-propagating worm, which became the Sammy worm. So basically, he added Sammy as my hero to his profile, by like anyone who viewed his profile, it what do you call it? Immediately infected their own profile, and that would be added to their bio too. So in the grand scheme of things, it was a pretty harmless XSS one, but nevertheless, it's a real life example of it. And yeah, that's my presentation on it.
Very nice, Alian. Very nicely explained, right? Within and the example you took was it's also very, very nice.
Thank you
for that.
Thank you.
Yeah. So I just want you to put your views, like what anybody got chance to look at the report shared by the other guys, means the topics that assigned to you or explained by yesterday, right? But what about the topics of other reports? Have you did you got the time to refer those things or not?
I haven't looked into every single report that was sent in the chat yesterday.
What about other guys? Have you got the time to refer those reports?
Somewhat we got, but like not so precisely I went through. Yeah, just went through.
I request you all to refer the reports shared by each and everyone, right? It's not like that you will become master once you do your own topics, right? I've distributed among everyone so that your workload can become can reduce, right? But it's
Sure.
your duty to, what I can say, you have to refer everything by your own, right? You have to show your efforts in order to go more deeper into this, correct? So I just want your reviews regarding our sessions, right? Any kind of improvements do you need, or kind of the way I'm going, so that it is perfect or not? After doing two, 3 sessions, do you realize that will you be able to, what I can say, will you be able to complete this course and try to get some positions in the job market? So I just want your reviews regarding after these 2, 3 sessions.
Yeah, hi Bharat. Sessions are going, really good, and you are going stepwise, so we can understand it. Even, students from very other field, like who don't know about cybersecurity at all, so we can understand what you are saying, and you are going explaining each and every topic step by step. So yeah, and you are giving us fair feedback as well. So where we are lacking and where we need to improve, so we are liking it. I'm loving it.
Hi, brother. Yeah, as Lakshmi mentioned, like we do not belong to this industry, but still it's the introduction part, so we can understand it, as it might be in simple terms and very basic language, so we can understand the terms, and we are used to with cookies, malware, phishing. So it might be difficult to understand the terminology and everything. But yeah, as of now, it's good. And maybe, yeah, hope like in the future, also in the coming days, it would be easy for us to learn and improve us.
Yes, Bharat. we can understand, we try to understand, and yeah, we are trying our best as well.
So at the end, you must realize that the time you are spending behind these topics in a day or weekly, right? So you must realize by yourself, you must evaluate yourself, right? That you are spending the enough time for learning those topics and all that, right? And you are free to reach out to me on weekdays also in order to clear out some doubts and all that, right? So it's not a rocket science like that. If you didn't belong to the cybersecurity or IT background, it's not cup of your tea. So it's not like that, right? So first and foremost thing is not to start is the biggest drawback that we are following in our life, right? So if you show your willingness to learn a topic, right, it will definitely take you to a point where you spend enough time to learn those topics, to understand the concept behind those things. You will definitely reach out at a point where you can see yourself to stand in the market, in the job market, right? So how you find it, Alia?
No, I find the sessions good for sure. I think it goes step by step, and um, obviously this is my second session, so I'm just going off last week. But yeah, I liked last week a lot, and I like the fact that it's engaging a lot because you ask questions to us, so we have to answer. So it's not like we're just listening. You also have to, um, give answers and stuff, which I think further helps everything.
Guys, thank you very much for your feedbacks, right? So till now we have learned about the cybersecurity landscape, right? Different types of threats, right? What are the type of attacks? Attacker is trying to compromise the user accounts and all that, right? So in every scenario, there is some kind of communication is happening inside the infrastructure, right? Some communication in the form of data, correct? So please, so for example, if you're calling something, so someone, right, and the person is replying back to you, it means your message is reaching to that person, and person is replying back to you in some kind of response, right? It means there is some kind of communication, some kind of link is building in those two objects. It means that in you and that person, right? So whenever there is some kind of compromise or some kind of attack is happening, right, there is exchange of data between the system or server and the entity or an attacker, right? So for example, I'm trying to search something on Google, right, and it is responding back to me in some results, right? It means that the results that is coming on my page is there somewhere, it is stored somewhere, right, and it is coming to me, right? So we are going to learn in this topic how the networking infrastructure is built, right? What type of terminologies are used, what type of architectures are used by the network engineers to share the data between the two systems, right? So the first and foremost thing is we are going to learn about the fundamentals of the networks and protocols, right? So first of all, let's understand the network, right? It's just infrastructure, right? It's the connection between the different nodes, different computers, and with the servers and all that, right? So it involves the best practices to for connecting to two or more computers, right? To share the data, to share the resources, right? So these type of connecting nodes are interconnected in such a way that they can able to share some data with each other, right? So for sharing the data, right? First of all, we have to follow some guidelines. Means we have to follow some rules, right? In computer language, we can say it as a protocols, right? So these are some rules and standards designed by the what we can say the network engineers that allow the devices to communicate with each other effectively, right? Without any kind of interruption, right? So, for example, Yamini, you are working somewhere, right?
Sorry?
You are working somewhere, right?
Yeah, yeah.
Yeah. So, can you just explain me what type of job that you are doing right now? Are you using some laptops, computers to share the data?
Hmm. I work in Heathrow Airport as a baggage screener, and there we have to do the like when the passenger drop the bags on a checking desk, then that bags is come to the uh, like screening area, and then we have to check each and every bag what's
Right.
inside the bags.
Mhm.
So we have to use the different type of icons how to analyze the bags, like a dangerous good, any suspicious item, or any something is going wrong to the aircraft. We have to check all those things. So yes, this is very private and confidential things.
Right. So have you sometimes encountered like so whatever baggages that you received at the airport, right?
Hmm.
So those baggages are are those ones which passengers what I can say used at the time of checking the flight, right?
Hmm.
So that it doesn't like you are seeing the physical bags and all that, right? But that data is coming to you, right? So and so bag is allocated to that person, right? The name and everything is assigned on that particular pass, right?
No, there is a no name, just only the bag tag number. We don't
Bag
know
tag,
which
correct?
person bag is, but
Right.
we get the tag number. Yeah.
Right. So whenever that person takes the bag, right, it is taking his own bags, right? It's not like that he is taking someone other's bag and take it to their home, right? So it
Hmm.
means that tag number contains some information, right,
Yes.
at the time of checking. So whenever a person is checking into the airport, right, he is just give his bags, right? They will take the what I can say that confirmation numbers and all that, and some type of information is getting stored on the tag number, right?
Yes.
Correct. So the person is from India. He is checking in the bag, and that bag and tag information is coming to London. Correct.
Yes.
So there is some kind of communication, some kind of networking is happening, right? It means the information from India is coming to you in the London, right? Correct.
Yeah.
So in this scenario, we can say that there is some kind of connection between the agency in the London and the agency in India, right? So it's everything is happening online, right? With the help of internet, correct?
Hmm.
So in terms of internet and everything is happening online, right? Then it is called as the networking and protocols, right? So in order to facilitate this sharing of data from India to London, right, we need to follow certain rules and certain standards, right? So some kind of infrastructure was built up by the company, whatever airlines that you are using, right? And that airline infrastructure shares the information with the airlines with the in London, correct? So for that purpose, there might be some certain servers, right? Server means the centralized system, right? Where we can store the data of our organization, right? It could be a website, it could be a database, it could be a file, right? It could be anything, right? So in this diagram, if you look carefully, right? So these are the certain servers, right? And these are the machines which are connected to these particular servers, right? And this is the internet, right? So with the help of internet, you are getting connected to these servers, right? It means, for example, this is the site which is located in India. This is in the London. This is in the United States. So different location, but they are getting connected to the centralized server, for example, in Japan, right? So these are the server located in Japan, can able to share the information in London as well as in India and as well as other location with the help of internet, right? So there is some kind of link is connected. See, from here, from here, from here, everywhere there is some kind of link is happening. Link is connected to the particular server, right? So if you look at the fundamentals, right? So in this diagram, if you look very carefully, so there is one node. These are the terminologies, right, which can be used in the networking concept. So first one is the node, second one is the link, and the entire connection is called the network, right? So node is the any device, right? In previous example, the laptops, the computers, the servers, everything is called a device. Means the device which is connected to a network infrastructure of the company is called the node. It could be a mobile, it could be a laptop, it could be a printer, it could be a router, switches, anything, right? So this is called a node. The link which is connecting the two nodes, right? The path which is connecting two nodes is called the link, right? Means through this path, node 1 and node 2 can communicate with each other, can share the data, right? For example, this node, right, which is located first on the starting, right? So this node wants to share or the data with this node, right? So the actual path would be, it will this node will try to coordinate with this node, and this node will pass the information to this, right? So this is called a link, a path through which a data can be shared by the two systems or two nodes, right? And the entire connection is called the network, right? It means the interconnected connection of the nodes, computers, devices, printers, routers is called a computer network, right? So I hope you understand about the network, nodes, links, right? So different types of what we can say the network, we can say different types of networks are there in the network architecture are there in the market, right? So first of all, the first one is the peer-to-peer connection, right? Means peer-to-peer connection means it's the direct connection between the two laptops or two computers, right? So there are some, if in the diagram, if you look at the two systems, they are getting directly connected with each other, right? So this is called a peer-to-peer network. So every computer is connected to each and every devices, right? So they are connected with linked with together with equal privilege and responsibilities of sharing the data. So right, so it can, this type of peer-to-peer networks can be useful in the smaller environment, like in simple office there are less than 10 computers, right? So we can use the LAN cable to connect those 10 computers with each other, and they can share the data, right? But there is no centralized system, right? So sorry, peer-to-peer, right? So there is no such centralized system. The computers can directly connect with each other, right? And they have equal privileges and responsibilities for processing the data, right? Now, if a user wants to share some data, see in this connection, right? This user wants to share the data to this computer, right? So there is certain path that needs to be followed by this system, right? So what, there are many paths, right? This computer can share the data to this computer can share data to this, and then it can share data to this system, right? Correct. But at this stage, there are several paths, right? This is the path that can be followed, this is the path that can be followed, right? And this is the path that can be followed. But right now that system has to decide, right, which path is the shortest path, and the data will reach to this system in most quickest form, means fastest it can communicate. So this is the path through which this system can easily connect with quickly send the data to this node, right? So this is the in between this path only one system was coming, right? So at this stage, there are certain mechanisms, there are certain protocols are followed by, certain privileges are given to this particular system that can decide this shortest path and how quickly that the node can communicate with this system very fast, right? So this is the what we can say the peer-to-peer network, right? The second thing is the client-server architecture, right? So client-server architecture is the most popular architecture in today's world, right? So they in most of the companies, in most of the environment, right? So let's look at some advantages of peer-to-peer network, right? So if it is feasible in the I mean smaller areas where there are not more than 10 computers, right? One computer stops working, then other computers will also, means if one computer stops working but other computer is working, then you can easily share the data with through other paths also, right? And it is very easy to set up and maintain the computers easily by itself, right? But the disadvantages is like that it doesn't contain a centralized system, right? So if there is more than 10 to 15 computers, it becomes difficult for an engineer to manage that particular network, right? And the security issue will also be major concern about the security of the data, right? Let's look at the client server architecture, right? So client server architecture is like a centralized system, right? Which in each and every website nowadays is following the same architecture, right? So for example, I am running a company and I have my 10 employees, which is located across multiple locations, right? So in that case, I have my 10 users, right? And I want these 10 users to communicate with peer-to-peer network. Is it possible? No, because they are located globally. They are working from multiple locations. So peer-to-peer network is not feasible in this scenario, right? So in that case, I have to design a network which must have a centralized system, right? Through which my 10 users in my company can connect with that particular server and can share the data, right? So client server is a network model, right? It is designed for the users called clients and to access the resources like computers, your laptops, your printers, any other services. If you have your own, for example, Netflix is the best example for client server architecture, right? So Netflix has designed its own server on cloud, right? On AWS, right? They are using AWS cloud service as their centralized system. So they have stored movies, songs, everything on the cloud. And the users like us, with the users, right? They are called nodes or a client who are accessing those movies, resources, and songs for their purpose, right? So a centralized system is there, and the users, so centralized system for what we can say the Netflix is there on a cloud server, right? And they across the globe, the users are trying to access the resources, movies on their laptops and on their computers, right? So this is the example of what I can say the client server architecture, right? So whenever a user wants to communicate with the server, the user put some request to the server with the help of internet, and through internet the request goes to this centralized system, and the centralized system will respond you in terms of results that you are required, right? So this is the simple example of client server architecture, right? A centralized computer network, right? Centralized computer network means it's a kind of what we can say, a centralized system is there, and it is also kind of what we can say the client server architecture. And the central, if in this scenario, see these are the multiple sites are there, right? And multiple sites can communicate with each other through to this centralized computer network. Centralized computer network itself is the what we can say the infrastructure containing the what we can say the other servers, other nodes, other database server, web servers, and everything, right? So some kind of what I can say the infrastructure was built up in the network infrastructure and can easily communicate through that particular resources, right? So it's one of the most powerful one powerful computer is utilized to service one or more lower powered computers, right, in centralized systems. So and the nodes under the centralized architecture are not linked, but and they are only connected to that particular server, right? So primarily to what we can say the some components are the mainframe computers which can handle the processing, right, and linking the at least two mainframe systems to together via some network connections and all that, right? So this is the centralized systems, right? One most widely used system are called the distributed computing architecture, right? So have you used the ATM machines?
Yes.
Right?
Yeah.
You have used the ATM machines to withdraw your money, right? So for example, can you withdraw money from the ATM which is not which is not of that particular bank?
Yeah. Yeah. Yes.
Right? But so suppose for example, I'm withdrawing money from HSBC ATM machine, right? But my account is at Lloyd's. Can I withdraw money from HSBC ATM?
Yeah.
Right? You can.
Don't think so. We can.
You can. We can withdraw money, right? But my data is stored at the Lloyd's bank, right? My account is created in the Lloyd's bank. My data is with Lloyd's bank, right? But still I can withdraw money from the HSBC bank. How it is possible, right? So in this scenario, there is a concept called distributed computing, right? So there is one communication link between the different banks and all that, right? Through which a distributed connection of the data is maintained on every node, mean on every ATM machine, right? Which can coordinate with the bank server, right? They can verify the data with the bank server, and they can provide you the service that you want, right? So there are several slave nodes, we can say, means a kind of ATM machines, right? They are connected with a communication link. That communication link is also connected to a master controller node, right? It is there in the down, right? So it is master controlling node which is managing the centralized repository of the data, and whatever user wants to share, wants the resources, wants the services, that communication link will help to reach out to the master repository, and this repository can help the user to whatever withdraw the money or something like that, right? So these are the multiple ATM machines, and they are communicating with a communication link, and they will refer the master node or controller, right? And they can share the data or withdraw the money, right? Is it easy to understand with the help of example a distributed communication network?
Yeah. Yes.
Yeah.
So whenever someone asks you about the distributed computing architecture, the first example you must comes in your mind is the ATM infrastructure, right? So the next is the type of computer networks in our, what we can say, the infrastructure that we are generally following. Right? So type of infrastructure, can anybody have any idea regarding what type of networks that can be used?
We are talking about printer more than this.
Yes, right,
Yeah.
right.
Yeah. All the hardware and software which are the interconnected, which
Yes,
helps
right.
the computer to share the data.
Harsh, your voice is breaking.
Hardware software which helps to perform the to send or receive the data.
So
Am
there
I
are
audible?
different. Your voice is breaking, Harsh. No worries. So there are, whenever the computers in the network are communicating with each other, sharing some data, sharing some information with each other, sharing some resources with each other, they are connected in some patterns, right? There are different types of networking pattern can be seen based on the geographical location, based on the size of the company, based on the number of nodes and all that, right? So there are different types of networks can be categorized based on these type of criteria, like it's based on the size of the company, number of employees, geographical location. Everything is maintained by while categorizing the types of network, right? So first and most commonly used and most simple type of network is the local LAN, local area network, right? So it is basically designed in smaller geographical areas, like small building, right? In small office, right? So there is one centralized system, right, which can be a switch, a hub, or a router, right? And all the resources, mean all the nodes, laptops, computers, printers, everything are connected with the help of a cable that is called a LAN cable, right? So LAN cable is connecting all the resource, all the nodes, all the computers, printers, servers to a centralized switch or a router, or a, what we can say, router or a hub, right? Which can facilitate the communication between the two, between these type of devices, right? So for example, a laptop wants to send the wants to print, this laptop wants to print the a page from his laptop. So it will send a print command from this laptop. It will go to this switch. Switch will find out where printer is connected. It will check is this a printer, is this a printer, is this a... Once he finds the connection to printer, it will send the print command to this particular cable, and the printer will print a copy of data, right? This type of network we have already seen in our professional life, right? So whoever is working in a school, in airport, or in offices, or in corporate offices, right? So they are generally following this type of architecture, right? So it is designed for smaller office, right, where 10 to 15, 20 computers are connected with each other. It can be connected in smaller single building and all that, right? Second thing is the wide area network, right? So wide area network is generally what we can say, in single city, right? So there are multiple LANs, LAN 1, LAN 2, LAN 3, LAN 4. Our smaller networks are connected to a wide area network, then connected together, then it is called a wide area network, right? So for example, there is we might have you use some interconnecting device like router, switches, hubs, right? So here, if you can see, there is one device called gateway, right? This is a router or a hub or switch which connects the resources over here. There is also a router, switch, or hub which connects, provide connection between here. So every LAN has its own connection, right? And these LANs are connected to a WAN, right, with the help of this gateway, right? So in order, for example, my company has offices in 3 cities, correct? So what I'll do, I will create a smaller segment of LAN networks, local area network in every city, right? And with the help of gateway, I can connect to this particular WAN, right? And I can create a wide area network for my company to facilitate the communication between these resources, right? Sometimes I might require the information of, suppose this is my headquarters, these are my offices. This is in the, for example, in London, this is in Manchester, and this is in Leicester, right? And this is my headquarters, which is located in Scotland, correct? So sometimes I might require the information of this location, right? Or some employee information or some kind of information. Then I can use this wide area network to get connected with this LAN, and I can get the information to my what I can say, the headquarter, right? So this is called a wide area network, right? Last one is the metropolitan area network. Means this is the combination of LANs, WANs. These are the LAN and MAN are combined together to form what we can say, the metropolitan area network, right? So there are multiple cities, multiple locations, multiple LANs, multiple WANs are connected together to form a metropolitan area network. So these are the type of architecture, these are the type of network can be followed by the companies based on their requirement, based on their size, based on their geographical location. Correct? Easy to understand what is LAN, what is MAN, what is WAN? Any doubts here?
Yeah, Bharat, can we
Yes,
relate? Can we relate? Like, as you said, LAN to peer-to-peer network, because they are exactly like, same. Can't understand
yes,
peer-to-peer.
yes. See, architecture is like is can be LAN is like it can be a centralized system like client server also, right? But it depends. If there are 5 to 10 computers, then there is no requirement of the server in centralized system. You can use direct cable, you can use peer-to-peer network in order to share the information, right?
Just like office work, office
Yes,
computer.
exactly. Yes,
I
office
Bharat,
computers.
you explain by layer by layer, and you explain like that, na, layer by layer.
Right, yes.
Yes, yes.
Right. So yeah, that can be you see, architecture I can follow anything. I can follow client server for my office. I can follow the peer-to-peer also, right? But it depends on the requirement. Like for example, I have my own website, right? I have my own website, and in a small office there are 10 users, and then they want to communicate with my website. Then it's then to use peer-to-peer network, it's very easy for me to implement the client server architecture, right? For peer-to-peer, I need to have the physical cable connected to that particular server. How many cables for connecting 10 computers to my server centralized system? I need 10 cables, right? So in that case, what I have done, for example, I have created one network. I have connected my server, and I have 10 users, right? What I'll do, I'll provide them as a Wi-Fi and ID password. They can directly connect with each other and can share the information with my server, right? So architecture is depend on us, that what kind of need was there, and based on that need, I can use a client server or peer-to-peer or distributed, right?
Okay.
But these are the type of network. Suppose in our daily to day life, right? We have seen we are connected with what we can say, the internet, right? We generally use in single office, they will use a LAN. In across the cities or a multiple location, they will use WAN, and for multiple location, multiple cities and countries, they might be using the MANs, right? So these are the type of computer networks we generally follow in computer network, right? So next topic is the network topologies, right? Network topologies means the pattern of connection between the computers, right? So if we look at the if we want to share some information with two person, right? We can directly connect with them, right? So in order to facilitate the communication between the computers or servers, there are pattern of connections, right? So first topology is the bus topologies, right? Suppose, for example, in first picture, if you look at that, there is one centralized connection between the two, between all the computers, right? If you look at that, there is centralized tunnel, right? And to that tunnel, all the computers are connected with each other. This is the most simple and most commonly used, not commonly used, most simple connection of the computers in the network, right? So for example, this computer wants to share the data with this computer. It will utilize this tunnel, and it can easily communicate with each other, right? But for example, due to some crisis, this computer got down. Means this channel is having some problem, right? So this computer, if this computer wants to share the data, wants to connect it with this computer, in this case, it will not be possible because this computer is down, this channel is down at this point, right? So for this reason, most of the companies are not using this architecture, because if it is connected to single tunnel and one of the computer is down, the whole network is going to be disrupted, correct, in bus topology, right? So if you working somewhere, then you can relate this example with yourself, right? But I'm explaining why they are using or why they are not using these networks like that. These are some advantages and disadvantages of this. This is the most simple. If you want to add new node, you can just plug a cable and you can easily connect your node to a network, right? But any of the node is not working, right? There is some problem, then whole network connection will going to be affected, right? So this is the reason behind they are not using the bus topology. The second topology is called the star topology. Star topology is like star, right? It means there is one centralized device which facilitate the connection between all the devices, device 1, device 2, device 3, device 4, device 5. These all devices are connected to this centralized hub, correct? Now, suppose device 1 wants to wants to send the data to device 4, right? So what link it will follow? It will send the data to the centralized hub, and then hub will decide that the data is for device 4, and it will send the data to device 4, right? But for example, this hub is down, right? This hub is down and it is not functioning, right? It is not functioning due to some power outage. This device is not working. So in that case, the whole infrastructure is not going to share any of the information with any of the devices. But in case of bus topology, if you look at this and this wants to communicate, this device and this device wants to communicate, but this node is down, right? Then it is not possible. But if this device and this device wants to share some information, then there is no outage. See, the line is clear, right? For this and this device is not working properly. So this and this not going to communicate with each other. But if this device wants to send the data to this, if the line is clear, it can send the information. But in this case, in star topology, if the centralized hub is down, the whole network system is going to down. So this is what we can say the drawback of star topology. But the connection is simple, right? Just add a single cable to add some nodes and all that. So it becomes very easy to maintain the network, right? This is the ring topology, right? This is the ring topology. It means all the nodes are connected with a circular cable, right? So anyone wants to send the data to particular any of the node, any of the computer, they will use the same channel, same cable to share the data, right? If at this point and this point, this line is not working, right? And this computer wants to send the data to this computer, then it will follow the separate another route, another link, right? From here it will send the data, right? But the connection is not going to be disrupted. If its base path is not working, it will use another path, correct? So this is called a ring topology. But if this computer is transferring the data to any of the system, then the whole cable was occupied, whole channel was occupied by a single network. Any other data, any other computer cannot send or cannot utilize any of the channel to share the information with any of the node, right? So this is the limitation behind the ring topology. Now the mesh topology. Mesh topology is like each and every node is connected to all the computers in our network. So this computer has the connection to this has the connection to this has the connection to each and every. So this is called the mesh topology, right? So in any of the scenario, in any of the condition, the worst condition, your network is not going to be disrupted. Any channel, it can, if one channel is down, it can utilize the other channels, right? If one computer is sharing the data with other computers, right? At the same time, different users can utilize the different channel to send the data, right? Means simultaneously multiple users can send and receive the data in mesh topology. And in most of the scenario, in most of the companies in present time, they are following mesh topology because the connection might be some complicated, right? But it can facilitate the communication at any point. So whenever some communication links are down, they can utilize the other links to send the data, and multiple nodes can send and receive the data in this network architecture, right? So these are the most commonly 4 type of topologies can be used by the network engineers to design the network infrastructure of the organization, right? Is it clear, guys? Any doubts still here? Any doubts?
It's more easy to understand this.
Right? It's very easy. It's not very difficult to understand. But these are some basics, right? In order to understand the network infrastructure, because the cyber security is itself is the part of networking, right? So you must understand the network infrastructure. What are the different types of network, right? This will help you to understand whenever some kind of breaches is happening, right? You can visualize the network, what type of topologies they have used, what type of connection are used by the systems to share the data, right? So these are some basic type of topologies that can be used by the network infrastructures, right? So let's take a break of almost 10 minutes, right? We'll back in 11:10.
Okay.
Okay. Right. Yeah.
Thank you. Thank you.
Meanwhile, if you have any doubt, please point out those things in your notepad so that we can clear out in the end of the session. Correct?
Okay, okay.
Yeah.
Okay, thank you, Bharat.
Thank you.
Hello, guys.
Hello.
Yeah, back again, everyone.
Yes, hello.
Gita, Yamini, you there?
Hello.
Okay, so the next topic is protocols. Right. So can you let me know like what is protocol? Any dictionary meaning of protocol?
Rules, set of rules or something. Messages, rules.
Exactly right, Rajshri.
Yeah, is a protocol is a set of rules for formatting and processing data.
Yes, right, Yamini. Any other one?
In networking, a protocol is what? Sorry.
Yes, go ahead.
It's doing certain action and formatting data so that two or more devices are able to communicate,
Mm-hmm.
communicate
Right.
with and understand each other.
So it's a set of rules that are
Set of
governing the communication between the two parties, right?
two parties, yeah.
So these are certain rules that are followed in terms of networking, right? So in order to communicate the two devices, there are fundamental protocols used, right, for relaying the data packets from different boundaries, like from the different networks and all that, right? So its primary process, pro, primary function of protocol is to deliver packet from source to destination, right?
Yeah, it's address or yeah,
Right, correct.
it's the right
So
place, yeah.
yes, so whenever you are sending some request to server, right? I think now I can use the terminology servers, protocols, routers, switches, hubs, right? So in order to, if you are sending some request to server, right, and in response to your request, server will send some response to it back to you,
Right.
right? For facilitating this communication between source, client, and server, right, there is what the very, what we can say, the protocol plays a vital role, critical role in this process, right? So it helps in addressing the finding out the address of the destination. It helps in routing packets from source to destination. It takes care of taking the packet from source, data from source, and send it back to the destination, right? So
address, yeah.
it also, the protocol also helps in fragmenting, means the data is of large size, right? Then it will fragment the data into smaller pieces, right? And these smaller pieces of data packets are again combined at the destination point with the help of these are the mechanisms are taken care by the protocols, right? Now there are two types of protocols that we are using, means IPv4 and IPv6, right? IPA, that we can say that it's a versioning of the protocol, right? There are two versions of protocol, IPv4 and IPv6, right? IPv4 is 32-bit protocol, 32-bit length, and IPv6 is 128-bit, right? I'll show you the example of this IPv4 and IPv6 protocols, right? So in order to communicate, in order to provide, or in order to facilitate the communication between the two parties, right? There are certain guidelines followed by the internet, right? Internet framework. So in computer networks, right, there is called a layered architecture, right? Layered architecture means the different what I can say, the sending data from source to destination is taken care by the 7-layer architectures, right? So for the 7-layer architecture contains the 7 layers, right? First one is the physical layer, second is the data link layer, third one is the network layer, fourth is transport layer, fifth is session layer, sixth is presentation layer, and last one is the application layer, right? So if you have studied in your graduation and in your colleges, like, you might have heard about this type of OSI layer model, right? So which facilitate the communication between the source and destination, right? So the role of OSI model is highly important while we are sending data from source to destination, right? The assembly and de-assembly of the data is taken care by the OSI layers, correct? So it's a conceptual framework, and it is used to understand and implement the standardized network protocols in 7 distinct layers, right? So at each and every layer, right, if you look at the diagram, right, there is a terms called TCP, UDP, IP, ICMP, IPsec, IGMP, right? So these are the protocols that are functioning at that particular layer, right? I'll let you know later what is TCP, what is UDP, what is the ICMP, IGMP. Everything I will discuss in later sessions, right? So there are different types of protocols are functioning at different layers, right? So whenever we are transferring the data from source to destination, right, first of all, your data is getting converted into electrical signals, right? So whenever you transfer the data, it will only get transferred in terms of electrical signals, right? So first of all, your data is getting converted into electrical signals, right? So at which point these electrical signals are getting transferred from source to destination, right? So what is happening? So let's understand first of all, let's understand the different layers. What is the function of physical layer? What is the data link layer, right? So what physical layer does? It will transmit the raw bit of streams into physical mediums. Means Physical layer takes care of transferring the bits in terms of electrical signals, right? At this point, whatever data you have movies or you have pictures or you have documents, these data, first of all, gets converted into the raw streams, or we can say the electrical signals, right? And these electrical signals are taken care at the physical layer, right? Its responsibility is to define the connection between the cables, switches, networks, network devices, hubs, and all that, right? So at physical layer, this data, it manages the encoding of data, signaling, and transmission at the point of physical layer. It specifies the high voltage levels, timings, and data rates, right? So what are the types of devices that are working at physical layer? It's like routers, hubs, repeaters, cables. These are the type of devices that are working at physical layer, right? So the basic idea, basic intention behind working at the physical layer is the encoding of data, transmitting into the signals, right? With the help of it ensures that the cable connections are working perfectly with the switches and network devices and all that, right? At data link layer, this is the all about the first layer. It means the physical layer. At data link layer, right? It is responsible for node-to-node transfer, means two systems are connected and it is responsible for sending data from source to the destination, right? So what is happening? What is the responsibility of this data link layer? First of all, it frames the data into the packets, right? If you have large number of data in terms of GBs and all that, right? So first of all, it will divide the data into smaller packets. Sorry. So your data is now converted into smaller packets and ready for the transmission, right? It also manages the physical address of the device, means where the source destination of address of the device, right? And also detects whether the integrity, means the data packets which are formed at the source is exactly same as the destination. So first principle of the CIA tried is coming at the second layer of the OSI model. It means the integrity of the data, right? There are various methods we can use to maintain the integrity, like hash code or checksum or something like that, right? So at data link layer, it will be responsible for node-to-node transfer from source to destination, right? In terms, it also handles the error correction and detection while reassembly of the GBs of data of smaller packets into a single unit. Right? There are high chances of getting the packets are misplaced, or there might be a chance of getting error, right? So data link layer, it handles the integrity by the checking the error detection, by checking the checksum, and maintain the integrity of the data, right? And at third layer, it's the network layer, right? It means the data, now your packets of data are now in the network, means different routes. So it handles the routing of and forwarding. Means routing means the sending packets from which route it is following, right? So at network layer handles the data when it is in the transit, means it is in the network channel, right? So it will decide which route it should follow to send the data to that destination, right? So it handles the routing and forwarding of packet from source to destination in transit, right? So it also handles there are two types of address for the system. One is MAC address and one is IP address. MAC address is the physical address of the system, and IP address is the address of the system when it is connected to a network, right? So at physical layer, it is taking care of the MAC address and the IP address when it is in the network, when your computer is connected to the network. So network layer responsible for locating the IP address of the destination system, right? What it is doing, it is taking care of the routing, means which route it should follow, right? And then the packet is forwarded to that particular destination. It is also responsible for addressing IP address of the, means which device is going to receive this packet, and routing is from different channels, means different routes can be taken by the what we can say, the packets to reach to the destination. And the fragmentation and reassembly, right? So all the packets of data are transferred in packets. Data needs to get reassembled at the destination, right? So network layer is responsible for reassembly of the packets, right? The fourth layer is called the transport layer, right? Transport means, for example, if you want to send some goods from London to Manchester, right? So what we can do, we can rely on some kind of vehicles, right? And we can load that data and we can give him the address, and that vehicle will, driver will take the goods to that particular address, right? So at transport layer, it provides the reliable data transfer between the source and destination, right? It's not like that we are giving to anyone any vehicle who will take the our goods to the destination. We'll check the reliability, whether it will send that, it is properly take care of the data and properly send the data to our destination, right? So at transport layer, it takes care of the reliable data transfer, right? Establish and maintain the connections, right? Means there must not be packet loss, right? If a packet was designed to follow the same follow a route, that particular route must be followed till the end of the data when it reaches to the destination, right? So it implements the flow control, right? So it is implementing the flow control, means it is not like that the packet are lost in the network. So flow control is taken care by the what we can say, the transport layer, and takes care of the reliable transfer of the data between the source and destination, right? So different types of protocol that might be working, like TCP, UDP, and also we can use the devices like firewalls to check the data, right? At session layer, when now the data is at your destination, it means at your doorstep. Now then comes the session layer, right? So session means whenever there is a connection between the two parties, right? So for example, I want to send my goods from London to Manchester, right? I approach one driver and ask how much time will it take to reach these goods to my destination. So it will give some time range, means in 5 hours or 6 hours or 7 hours, I will be reached to your destination. So when my goods loaded in van and starts journey, so my session starts, right? And when it reaches to my doorstep, the session stops, right? So whenever I'm trying to send some data from source to destination, session layer is maintaining the session of the transfer of data between the applications, correct? So it is managing the session that the session must be active between these and this time frame till the data reaches from source to destination, right? Its responsibility is to establish and manages and terminates the session, means what it is doing, It will start the session when I start sending the data. It will manage in between the whole path. And when the data reaches to my destination, it will terminate the session over there. Right? So this is the flow which is taken care by the session layer, right? And it also synchronizes the exchange between the applications, right? So it is maintaining an exchange between the whenever data is used by some application. So it is it keeps track of those data, right? And after that, there is when the everything session is maintained, everything is perfect, right? That the second last layer is the presentation layer. Means the data is now at your doorstep. The session is maintained. All the data packets are here. Now it's time to decode. Means at the time of sending the data, suppose some kind of encoding process had happened. So at presentation layer, these data is getting decoded. If it is encrypted at presentation layer, it is getting decrypted. So it is ensuring that the usable format, means the data packets are arranged in the format when I send the data, or when the format was maintained at the time of sending the data, right? It means the packets are getting rearranged in the proper format at presentation layer. Now at application layer, once the data is properly arranged, now it's the time for you to use that data for your purpose. Means provide the network service directly to the user. Means it is facilitating the user that an interface that application access to that particular network and services, right? So at application layer, your data is well proper arranged, and now it can be used by it can be used by you to as per your requirement, right? So for example, I am transferring a data for example, I'm downloading a movie of 5 GB, right? So it is not possible for a network layer architecture to transfer whole 5 GB of data in single go, right? What it will do, it will bifurcate, it will fragment the data into smaller units. For example, I'm taking example 250 MB, right? 200 megabytes of data packets are created, and those data bytes of data are sent across the network, right? And then at application layer, it can be used by your application, whatever the purpose of your application that you have acquired that data, right? So this is the layered architecture, right? At data link layer, the data is getting what we can say converted into electrical signals, right? At physical layer, right? A proper encoding is maintained, and the specify high voltage level and timing the data rates are maintained at physical layer. At the data link layer, it is responsible for node to node data transfer, right? Where handles the error correction and all that, right? At network layer, it is taking care of the routing, means what path it should follow, addressing, right? And fragmentation and reassembly of the packet is taken care by the network layer. Transport layer is responsible for reliable connection between the source and the destination, right? At session layer is maintaining the session of the session, right, of sending the data from source to destination, and it is responsible for establishing, managing, and terminating the sessions, right? Presentation layer, it means they can be what we can say, the data are getting reassembled, proper decryption process is happened, proper decoding is done, right? And if it is the data compressed, then it is bring back to the original forms, right? So these type of that task is responsible for presentation layer. And lastly, the application layer, for which particular application that you downloaded that particular data is presented back to the same format as it is sent on the by the source, right? So if you look at the transfer of data from source to destination, see, this is the sender who is sending the data, and this is the destination, means who is going to receive the data, right? So what it will do, I have one image file, right? And I want this image file to, for example, I have one document file, right? I want this document file to be sent to this destination recipient, right? So what I'll do, first of all, I'll go to application. I have my application to open that particular file. I will go to then the data is transferred to presentation, means how it is presented. Now I will maintain the session of the data. I want to send it to particular destination. So at this, the session is started at particular time frame. Now these are at this point, the data is in the original form. It is in the document form, right? When it comes to transport layer, the data starts getting defragmented, right? It means there are something is getting added to that particular data. Means at transport layer, your data stream is embedded with segment header, right? Segment header means it is a reliable connection between the source and the destination, right? And after that, when it comes to network layer, right? When the data comes to the network layer, the data is it starts breaking into smaller segments, right? Where it is embedded with the packet headers, right? So that data is getting converted into smaller units, and the packet header is added at the start of each and every packet, so that at the destination side, when it reaches to that particular destination at network layer, these data packet headers are getting removed, and proper sequencing is maintained at the network layer, right? And when the data comes to network data link layer, right, it is getting means it is getting converted into smaller packets. And when it comes to physical layer, it is getting converted into electrical signals, right? So for example, I am sending the data through email, right? I can see that I opened the Outlook, I attached that file, and I I added the address of the recipient, right? So destination, and just clicked on the send button, right? But in the back end of your system, in the back end, in the network architecture, it is following these many of the steps for sending the data from source to destination, right? So for example, when it is in the original format over here, when I clicked on send, it is converted into electrical signal, right? It means my data is getting encapsulated, is getting secured, is getting some encryption is happening in my data. Now when it reaches to the destination, so first of all, when I send the data, it starts with application, but when I receive the data, it starts with physical layer, right? So at physical layer, all the electrical signals of this particular document is getting accumulated over here, right? And at data link layer, the reverse process of the encapsulation process we have done here, the reverse process of decapsulation is happening at this point, right? So all the electrical signals are accumulated over here, proper sequencing is maintained, right? That it ensures that the node to node means all the data packets are reached to the destination, right? At network layer, it will arrange the data in proper sequence by removing the data packets, right? Now at transport layer, when the data goes to transport layer, original form of the data is maintained, and it removes the segment header which was sent at the time of source when sending the data to destination, right? And at session layer, it is maintaining the session. So when it starts sending the data, and when it receives the data at destination, the session is maintained by the session layer. Presentation layer, the data is going to be presented in the human readable form, right? Whether it is in the document or in the image file or a video file, or could be a movie, right? And at application layer, the data is going to be used by you for your application, right? So this is the process that is happening in the back end while we are sending a data from source to destination, right? Whether it is a client server architecture, whether it is a peer-to-peer network, whether it is a distributed, whether it is a centralized system, his OSI model is always remains the same, right? I hope this model is clear to all of you, right? If you have any doubts, if you have any queries at any point, at any layer, please let me know. Please let me know. I hope it is very easily explained to all of you. I hope the silence shows that it is clear to all of you, or it is not clear to all of you. What I understood, what I can understand is.
But I think, yeah, if we will go through a recording one more time, we will understand it better.
Yeah, it's not that much clear.
Yes, yeah. You go through the recording once again.
Yeah.
Try to read about this OSI model. It's very important, right? In every interview questions they are asking, please explain the OSI model. Please explain the client server architecture. Please explain CIA rights, right? So this is how in computer networks they are maintaining the CIA rights by encryption, by making data available, by using load balancer whenever there is outage. So some kind of mechanisms are adding so that the proper security and the proper availability of data is maintained while when we are communicating with the server, right? So I hope this OSI model is clear to all of you, right? Any doubts, any queries, please. If you fully understand, then is also okay. If you are not getting anything, please let me know. I will explain it again. Right?
Yes, okay, Bharat. Yeah.
So yes, Yamin.
Yeah, share this recording as well. So whenever we get chance and whenever we are free, so we can just reopen and just try to understand. And if we are stucking anywhere, so I will call you. We will call.
So there are certain networking protocols, right? Whenever we are working on internet, we need to follow some key protocols in order to share the data with the source, with server and all that, right? So there is called HTTP, means hypertext transfer protocol, right? And the S is for security, right? So this protocol is for transferring web pages on the internet when you are finding something on your browsers.
Yes.
Right?
Yes.
So this is called HTTP. So whenever you are if you are using any website, right? So and in the address bar you will find the HTTPS or HTTP, right, in the beginning of your website name, right? So this is called the HTTP protocol, right? HTTP service in order to communicate, in order to make available this website through on my server, I have to utilize the HTTP protocol to make available my website to the public, right? Second is the TCPIP, Transmission Control Protocol, Internet Protocol, right? It is the core of the internet, right? Without the TCPIP, you are not able to maintain or ensure the reliable connection between the system, between the and you cannot ensure the reliable transmission of the data, right? So TCP is responsible for reliable transmission, reliable connection, and IP is responsible for addressing and routing, means which route the packet should follow to reach to the destination, right? So TCP is the connection oriented, means you have to provide certain type of connection in order to, from source to destination, to transfer the data, right? So TCP is the connection oriented. Second thing is the UDP, user datagram protocol, right? It is the connectionless, right? It is the connectionless protocol which allows a fast data transmission, fastest data transmission, but it is less reliable. There might be a chances of dropping the packet and all that, right? So for reliable transmission, we are using TCP/IP, right? And it is a connection oriented. But if we want to use the connectionless, then we can use the UDP, user datagram protocol, right? These protocols are working at the different layers, right? So that's why we are understanding that, right? And we will also when we are we'll go more deeper into this. We will learn this protocol as a services in the server, right? So just learn this for the time being. We'll discuss more in detail when we are going more deeper into this, right? So user datagram is the connectionless protocol, and it allows a fast data transmission, but it is less reliable. There are more chances of losing the data packets, right? Now the third next is the file transfer protocol, FTP, right? It is used for transferring files between the systems, right? Second thing is the SMTP, Simple Mail Transfer Protocol, right? This protocol is used by the mail servers to for sending the emails to the recipients, right? So whenever there are emails regarding phishing or something like lucrative offers, right? What we can say, the attacker is also maintaining the SMTP protocol to send the data, to send the phishing emails, lucrative emails to the senders, right? So SMTP's protocol enables the email services. Next is the POP3, means Post Office Protocol. Sorry, O is not mentioned in that, but it is POP, right? POP3 or IMAP means Post Office Protocol or Internet Message Access Protocol. It is also used for the receiving and sending the emails, right? Sorry, for SMTP is used for sending the emails, and IMAP, Internet Message Access Protocol, is used for receiving the email, right?
What do you mean receiving the email?
Receiving, to receive something.
Receive, oh, sorry, receiving email, sorry.
It's not receiving email, right? So for if I want to send email to some destination, I have to enable SMTP protocol. But if I want to receive some data emails from the source, I have to enable POP3 or IMAP protocol in my system, right? Is that simple? Next is the DNS, domain name system, right? It's very important to learn about DNS, right? So we know that every website has its own name, like google.com has its own name, Google, right? If you are searching some website, we are typing some website name in the address bar of the browser, right? But whenever we are typing a website name right? It is pointing to some address, right? For machine, right? It's very machine can only understand the binary language or yes or no, right? So whenever you are typing some name in the address bar, these names are getting converted into some IP in numbers. These numbers could be IP address like 192.168.10.5 or something like that. Correct? So DNS system facilitates that instead of remembering the lots of IP address, it becomes rather remembering the IP address, you just remember the website, right? So whenever I'm typing google.com, it is pointing to certain IP address, right? So there is a relief of for remembering the IP address of Google. If I'll tell you like please search something on 192.168.10.5, right? But and if I tell you that please search on Google these things, right?
Mhm.
So it becomes easy for you to remember the website name rather than the IP address, right?
Right,
Next
yeah.
is the DHCP, Dynamic Host Configuration Protocol, right? So whenever you are getting connected to internet, right, you will be assigned an IP address, right? Two type of address I just explained you. One is the MAC address and second is the IP address. MAC address is the physical address of your system, means that is not going to be changed, right? In any circumstances, any scenario, your MAC address is not going to be changed. It is going to be static, but the IP address is dynamic, right? So whenever you are getting connected to a network, means you are getting connected to what we can say a Wi-Fi from your home and Wi-Fi at the railway station or airport, right? And if you check the IP address of your if you check your IP address at home, then that IP address is different. And if you check the IP address while connected to uh, airport Wi-Fi, then the IP address would be different, right? So IP address is keep on changing at whenever you are changing the network, right? So there is one protocol called DHCP which manages the IP addresses whenever you are connecting to a network, right? So IP address is kind of address, is a logical address given to you, while you are sending or receiving some data. See, whenever you are connected to a network, yeah, right, you must require an IP address, right? After connecting to a network, you are not going to sit idle. You are going to search something on Google. You try to search something. You try to access the resources of your organization, right? So to receive that particular resources, where that resources come to you, that can be identified with the help of IP address. Correct? So this is the importance of IP address. So whenever you are changing the network, the logical address of your system is getting changed, and that can be facilitated by the dynamic host configuration protocol. So whenever you change the network, your IP address will get changed. Whenever you go to connect your office network, your IP address will be different.
Mhm.
Out of these keywords, these protocols, any of the protocol which is not cup of your tea, please let me know. I can explain you one more time. Is it easy to understand or not?
Yes, it is easy to understand, and we are trying to find out more in a Google as well.
Right. So what I'll give you an assignment today, right? I want you see, now it is getting more deeper, right? So you may find it some difficulty for learning these more technical terms. So I would request you to please read about these things of the today's session, right? Please utilize your time properly. Please try to spend 1 or 2 hours behind these topics, right? Because we are following proper channel, proper path, right, in order to understand the security operation of the infrastructure, right? If these things are clear to all of you, it becomes very simple for you and easy for you to what we can manage the security of operation of the company, right? So please refer, please read about this, please come up with some examples, right? Please come up with your doubts, right? After learning these types of topics, I'm assuming that you have not fully grasped everything, right? There might be some doubts, some queries, and you should have some queries at this point, right? So please read about this. Please read about these protocols. Please read about this OSI layer architecture, how it is working. In next lecture, I'm going to ask you the questions from this session because it is very important. The networking concepts are very important. It's not whenever you are managing the security operation, you are not going to manage the secure network infrastructure, right? But you must have the proper understanding, proper flow of the data, proper protocol assignment on the OSI layer. It's very important, right? So whenever you explain something, that person is going to analyze these things only, right? So please read about this. I hope you will come up with some doubts, some queries, and if you fully understood these topics, and I hope that you will bring some examples to me so that we can discuss in the next section, next session. And if you feel and if you find any doubts, I will clarify it on Saturdays, right? So thank you very much for everyone for joining the call. And if you have any queries, we can discuss it now, or otherwise you can wind up the call.
Yeah, thank you, Bharat. Yeah, maybe I will, one more go through with the recordings and everything, examples, and then come up with the queries on Saturdays.
Okay.
Yeah.
Thanks,
Yeah.
Rajshri.
Yeah, and Bharat, yes, next Sunday I'm not available, but Saturday I will join.
Yeah, sure, no worries. We'll try to cover up some topics on Saturday also. Right?
And please send this recording to me as well. So yeah,
I will post it in our WhatsApp group, right?
yeah. Thank you so much.
Yeah. Thank you.
Thank you everyone for joining the call.
everyone.
Bye-bye.
Thank you,
Bye.
Bharat.
Thank you.